Hey guys, chapter 9 review again with the Rascals. Okay, so problem 1 is graph the figure and its image under the given reflection. AB with endpoints. A is 3, 2, and B is -8, -3. Reflected in the x-axis. So what I have done is I already have the graphs plotted. But what I did was I plotted AB, so I plotted the coordinates and I drew a line. And for A prime, I turn the y into a negative because you're reflecting on the x-axis. So you would change the y into a negative, and if you were vice versa, so if you were reflecting on the y-axis, you would change the x to a negative. But because you are reflecting on the x-axis, you would do that. So I did it. So I turned them into a negative, and I plotted it, and that's how you get AB prime. Okay, for problem 2, what are the coordinates of y prime after the reflection of x in the x-axis? So I have the original W is this one. So what I personally do is I subtract, like I count down, so it would be 1, 2, 3. So I would go 3 under 1, 2, 3, and I'll plot it. But because it's asking for the coordinates, it would be 1, 2, 3, 4, 5, 1, 2, 3. So it would be 5, -3. And that's how you do number 2. Okay, bless you. For problem 3, the directions are determine how many lines of symmetry the object has. So for the Batman design, I already have the line of symmetry drawn. So it would just be down the middle. So it would be 1 because you can't do any more lines this way, diagonal, like you can't make any more lines and have the same image on both sides, so it would be only 1 down the middle, so your answer would be C, 1. Okay, for number 4, it's the same as number 3, so it's determine how many lines of symmetry the object has. So I already have the lines drawn, so I have one line drawn straight down the middle because you would have the same image on both sides, and then horizontally down the middle because you would have the same image on both sides, and you couldn't do any other way, so your answer would be C, 2. Okay, number 5 is which transformation is best described in the figure shown? It would be, so the words are translation, rotation, reflection, and dilation. So dilation, it couldn't be dilation because it's not getting bigger or smaller. It couldn't be reflection because it's not reflecting along the x or the y axis. And it couldn't be rotation because it's not rotating. So it would have to be translation. So the answer is translation. The answer is A, translation, because it's moving and sliding. Okay, for 6, the original pictures look like this. So I'm gonna just go off of this because my drawings aren't the best. So for the 8 ball, you could have it down the middle. So you could have 2 for that one. You can have it down the middle. And you can have it like different ways if you just keep turning it. So for D, you could have it straight down the middle and straight down this line, and you would have the same image. And for B, for the snail shell, you wouldn't have one. And because the problem is which object does not exhibit rotational symmetry, it would be B because it doesn't have, you can't rotate it and have the same one. Like, so if you rotate the 8, you could have the same image instead of having to turn it 360. Same. So like, say if I turn this, I could have it a 180. And then for C, for the recycle sign, I could have it this way, I could have it this way, and I could have it this way, and it still wouldn't be 360. For the triangle, he could have it this way and this way, because it would still be the same image as the first one. And you could rotate it one more time to make it a 360, and it still wouldn't be, to make it 180, and it still wouldn't be a 360 turn. So if you rotate it this way, you wouldn't have the same image. So if you just keep rotating it, it wouldn't give you the same image as you started off with. So the answer would be B. Okay, so the directions for 7 and 8 are: graph the image of each figure under a translation by the given vector or rule. So I have the coordinates and the, I guess you would call it the vector, or like you subtract it. So this is the this would be the this is what they gave you, and a graph. So you plot the coordinates on the graph, which I have done. So it would be these. And how I got to the answers from the prime, I subtracted, so the vector, I guess you would call it, it's the a, -4, -3. So you would subtract this from all the x's, so it'd be 3, -1, 4. And the same for the y, so you would subtract -3 from 5, 3, and 2. And that's what I've done. So I'll show you how I did it. I'll show you once for the x and one for the y. So I'll do this first coordinates. So it's 4, 2, and the vector, it's -4, -3. So this is the x, so you'd subtract 4, and this is the 3, so you would subtract 3. And then that would turn out to cancel out, and that would be a 0, and this would be -1. So I plotted that, so it's 0, -1, so it's 0. This would be 0 right here, and then this is -1. So this would be x prime, and then you would just keep doing that for the rest of the problems, and you would get to have the and you would get the translation of the answer. So that's how you do problem 7. Okay, so problem 8 is just like problem 7, except you don't have a x to subtract from. So this would be x is 0 and y is 5. So you would take that and you would plot the coordinates of the problem. So so it's 1, -5, and 4, -3. So I plotted that. So it's 1, -5, and -4, -3. And I drew the line. And I labeled it. So for that, I did 1, -5, and you would subtract that by, or you would subtract or add it by 0 and +5. So for x, it's 0, and for y, it's 5. So this would cancel out to become 0, and this would be 1. So that would be 1, 0. So I would plot that. So I would do 1, 0. So this would be this would, ooh, I messed up. Wait, let me check that. I plotted that wrong, so I had to erase it. So this would be y prime, and for z, it's -4, -3. So I have that written down, and I would do the same thing, so it would be 0, 5. So you would subtract 4, so it would just be -4 because you're subtracting it from 0. and 5, -3, so that would be +2. And you would plot that. So it's -4, 2, and I have plot in here. 1, 2, 3, 4, +2, 1, 2. So that would be z prime. So that's how you do problem 8. Okay, for 9, the directions are find the translation rule that moves from dog to cat. So I went from the O in dog to the A in cat. So I went down 1, 2, 3, 4. So I put -4, and I went over 1, 2, 3, 4, 5. So I got -5. So the translation for it would be -4, -5, because it would be negative because you're going down and negative because you're going to the left. That's how you do problem 9. Okay, for problem 10, the directions are rotate the parallelogram 180 degrees clockwise about the origin. What would be the coordinate for R prime? So say this is the clock. This is the hand of the clock, and it rotates this way. So this would be clockwise because it's going the way of the clock, and this will be counterclockwise because it's going against the clock. So they want us to go clockwise, so we were going this way. So we would turn the paper like the hand of a clock. So when we turn the paper 90 degrees, 180. So once you turn it 180 degrees, you would go, because it's asking for R, you would start from 0 because you're trying to find the coordinates. So I went 1, 2, 3, 4, 5 over, so I have 5 right here, and 1, 2, 3, 4, 5, 6. So I have 6 right here. So the coordinates of R, if you flipped it back over, the coordinate for R prime would be 5, 6. No, it wouldn't be 5. It would be 5, -6, because you're going over 5 and down 6. So your answer would be 5, -6. Okay, for 11, my picture isn't the best drawing, so I'm just gonna use the packet. Okay, so this is a picture. The directions for number 11 is determine the scale factor of the dilation, determine whether the dilation is an enlargement or reduction of or congruent transformation. So I have this drawn, and the picture is, this is the old, so that's the old, and this is new, because it's a prime. So obviously it's an enlargement, it's getting bigger and it's not getting smaller. So I went over to here and I crossed out the reductions because it's not getting smaller. And the way you can tell if it's getting bigger, if it's by half of a size or by 2, because that's the only 2 answers that we have left, I count. So I would go up 1, well, that wouldn't even be a full circle. 1, 2, 1, 2, 1, 2, 1, well, that's not a full circle. 1, 2. So it just determines on how, looking at it, it wouldn't be a half of an inch bigger. It would be 2 inches bigger. So that's how I got the problem for for 11. Okay, for 12, the family photo originally measures 18 inches by 24 inches. needs to decrease a size of 3 by 4. Decrease to a size of 3 by 4. Find the scale factor. So for the formula is for the scale factor is nu over